Hey, it's Mitchell. Welcome to another video in the RSP education series. What if I told you that a single push button could be the difference between a smoothly running factory and a smoking burnt-out motor? Today, we're going to crack open motor starters and their pivotal role in industrial automation. From the brainy control circuits to life-saving protection, we're going to break down exactly how these systems keep your motors alive. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. Now, let's jump into it. First up, control circuits. This is the brain of your motor starter. Here's what makes it work. There's a start-stop circuit logic. So a basic motor circuit's going to use a start button for momentary, normally open contact, and a stop button for momentary, normally closed contact. Pressing start energizes the coil, closing the main contacts and running the motor. Stop cuts power, opening the circuit. Then you got seal-in or self-holding contacts. This is what makes the motor stay on after you release the start button. That's the work of a seal-in contact. So normally open or NO, auxiliary contact on the contactor, keeps the coil energized even after you let go. Stop breaks this loop, and this shuts everything down. So push buttons and selector switches, start, stop buttons, these are just the basics. Selector switches like hand, off, auto, these let you choose between manual and automatic control. Overload contact, that's normally closed in series with coil. If the motor overheats, the overload relay trips. This opens the contact and cuts the power to the coil, saving your motor from burning out. Now let's talk electrical protection. So motors are expensive, so we protect them. Here's how. Circuit breakers and fuses, obviously. These are going to stop catastrophic failures like short circuits by cutting power fast. Motor protection relays. These smart devices, they detect problems like phase loss, unbalanced or locked rotors before damage happens. Disconnect switches. So if you need to work on the motor safely, a disconnect switch makes sure there's no accidental power-ups. So some selection criteria for when you're selecting contactors. Picking the right contactor is very important. Here's what to check for. AC-3 duty rating. This rating means that the contactor is designed for starting and stopping squirrel cage motors, the most common type. Voltage and current ratings. You need to match the contactor's current rating to your motor's full load amps or FLA. Voltage needs to match too. Both coil voltage, typically 24 volt DC power, and 120 voltage, as well as line voltage, typically 480 or 600 volt. Number of poles. 3 pole for standard 3-phase motors, but some applications need extra auxiliary contacts. Check for environmental ratings, whether that's NEMA or IP, right? You're sticking this into a dusty environment or wet or corrosive. Pick NEMA 4X or IP65 for harsher environments. So let's recap. Control circuits are the brain, start-stop logic, sealing contacts, and overload protection keep things running. Protection elements like breakers and relays are the muscle that stop disasters before they happen. And picking the right contactor, that's the key. Right? You need to match the ratings, the duty, and environment to avoid costly failures. For a full line of contactors and starters and hundreds of thousands of other industrial automation products, please go to our website. That's rspsupply.com, the internet's top source for industrial hardware.